Hello friends, welcome to our website automationcommunity.com. In the last video, we have seen the ladder programming for servo motor. Today, we are going to see its HMI designing by using this Dpsoft HMI software. So let us start it. Click on the new file and let us select 800 by 600 resolution screen and write the name of our project. On the next button. In the communication, we have to select our simulator or the driver for our PLC and click on the finish button. So today, if you watch this video completely, you will learn some new things like how to create multiple screens and navigate to multiple screens in HMI, and besides that, how to give animations to rotating objects. So here also we will start from the most complex things, that is creating the rotating effect. So for that we will use the state graphic. So click on the picture display and here we will use state graphic. So let us draw a box of size like this and adjust it like this. So first of all, go to pictures and select image. So I will go to vector fan library. So here it is, and from here I have to use these images because it is starting from 120 and it is ending to 144. So there are 25 states. You can see 25 different images just for one rotation. So if we use this image with maximum images, then we can observe the movement very accurately, because we want to see the movement of 180 degree, 90 degree, like that. So we will select this. So first of all, go to mains and here you can see state counts. So because we have 24 images, so we have to select 24 states. Okay, we can give images. So go to pictures, first enter over here. So now you can see 23 over here. So let us go to 0. Now go to pictures and go to vector fan library. Remember, that was image number 120. So from here we have to select this, click on stretch all. Now our work is done. So in this way we have to add all the 24 images in proper sequence without missing any images. Like now here we have to select image number 121. So this is image number 121. Click on stretch all. This step is also important because if we don't do this, then some images will look like this, others will look like this, and we can't see the rotation properly. So in this way we have to add all the 24 images. So to make this video shorter, I am skipping that part. So friends, actually there were 25 images. So you can see from 0 to 24 I have added all the images. You can see in each I have added the images. After that, what you have to do, you have to write address for this animation. So click over here, and from here by default it will be look like this x1. You have to click on internal memory, and right now we will give its address to internal memory 1, because for animations we use the internal memory of HMI. So just you have to do 25 counts. After that you have to give images to all these 25 states from vector fan library. and you have to click OK. So our 25 states are created. We will move further. First of all, this screen is for Dpls V instruction. So what I will do, I will just add one text over here. Let us write. You can format your text from here. Make it bold, align it center like that, and you can write. You can further increase its size, and you can also change its color. You can also change background color from this foreground color. Click OK. Now it has two inputs, a number of frequency. So here I will enter one text box, and here I will write enter frequency. Let us correct this. We can make it bold, and let us align it left only, and we can increase its size and click OK. So it is looking properly. Similarly, just copy paste this block. Now we want another input from user, enter number of pulse. So here we will write number of pulse. Click OK, and we can stretch this. Now here we want two numeric entries so that we can get data from user. For that we will go to numeric input, here numeric entry, and draw a box like this. Let us format this so we can change its background color and also its text from here. Let us increase its size. Okay, further we can increase, and we can change its shape also. The main thing is the address. So our frequency is at our D2. So here we will write D2 address, and copy paste this in the read address. Click OK. Similarly, just copy paste this block so that we don't have to repeat the formatting steps. Just change it to D0 because our pulse number is stored at D0. We have created the two inputs. Now we want button over here to start this function. So what we will do, we will go to buttons. We want maintain button, and we will draw like this square box. Let us give one image. So go to pictures and D buttons. Let us give this image for off condition. Click on stretch all, and similarly for on condition we will go to same library and give this image. Now don't forget to give its address. So this will be our X0. So just write X0, enter, and click OK. So our button is also created. Now you can add further text as per your wish. Let us copy paste this. So actually this is simulator not showing all the functions. This is just showing the basic function or working of the PLSY instruction. So I will write we have to do, we want to put one button over here so that we can go to another screen. So first of all we have to create the screen. So how you can do that? Just click over here and right click over here, so you can see the option of new screen. So here you have to give the name of your screen. So let me write DPLSV. This will be the name of my screen name, and this will be the screen number. So we will select screen and click OK. So here you can see this is the complete blank screen. So what we will do, we have to draw one button over here through which we can switch between the screens. So go to buttons. Here you can see go to screens. So select over here. Now draw a button. Double click over it. So by default it is asking over here where you want to go. So here we will select to go DPLSV because this is our destination. Click OK. So now whenever this button will be pressed, it will go to this particular screen. Now here it is asking for internal address. So we can give internal memory like 10 because one we have already used. So we can give it's 10 and enter. Now write over here where we want to go, or you can write the screen name. So here I will write DPLSV, make it bold, increase its size only, and change its background color from here. Okay. So this is our complete design of screen number 1. So what I will do, I will just select all by pressing Ctrl A. So you can see all the things are selected because many of the things are going to repeat in my second screen. So you can see all the stuff has fit to here because you can see that we have to add 25 images to this. So we can't repeat all these steps. So what I will do, I will just delete this because Dpls V instruction only has one input, that is the frequency. So first of all, I will change over here Dpls V, and also let us change its text, its background color. Okay. Now here in the button, what we want to do, let us change its address, and here we want to move to our first screen. Now what we will do, first we will delete this button and we will select a new go to screen button, and let us write its address 11, press enter, and here by default it is screen number 1. So whenever this button is pressed, it will go to screen number 1. Now we will give its text like DPLS Y and increase its size, make it bold, and let us change its color. Here also in the button, because X0 will be used to start DPLSY instruction, so we have to select X1 over here. Frequency will be same in both. The next change I am going to do is here, because in the DPLSV instruction there is another output, that is direction. So direction I can't show over here in the animation of the rotation because HMI provides only positive rotation only. So what I will do, I will indicate the direction separately. So for that, go to indicator and draw a box like this, and I will select round shape over here, and the direction, you know, it is direction is available at output Y1. So what we will do, we will simply choose two colors for on off conditions like this and click OK. And here I will copy paste this. This will represent our direction. So in the text I will write direction, click OK. So if this is on, that means it is reverse direction. So let us write in here only. You can double click over it and go to text. So if this is on, it will be reverse, otherwise this will be forward. And make it bold so you can easily understand by yourself. So this is the complete designing, but the main thing that is giving life to this animation is writing a code. We have to write one macro code in screen. So go to screen and go to screen cycle macro. So what we have to do, we have to write one code for animation of this. And how to write that? So let us see how to write that. First of all, what I will do, I will click over here macro wizard, and here I will select comparison if and if on, and in the variable I will select y0, because from the y0, if y0 is on, then our servo motor will be on. So enter this and update macro and close this box. So I have started one if loop. So whenever you start if loop, the best practice is to first close this by end if, so that we don't forget to write how many end if we want to write like that. So it is best to write end if before only. Now inside this I will write my complete code. So there are the two cases, either the pulse number is 0 or the pulse number is greater than 0. Because in the real life, if you enter the pulse 0, so the servo motor rotates continuously. What I will do, I will go to macro wizard and go to same block if. This time I will write if equals to. So here I will select data register 0, because that is our pulse number, and in the second I will write the constant 0 and enter. Update the macro, close this. So you can see by default it will write instruction, so we don't have to write this stuff. Again what I will do, I will end this loop by writing end if. Within this I will write my code. Again I will write one if loop. If value of internal memory 1 is greater than, greater than equal to 0. What is internal memory 1? Internal memory 1 is the address of this element. Okay, it has 25 states. So if I write internal memory 1 equals to 1, it will show the image stored at one position. Similarly, for the different values of internal memory 1, it will show different images, and based on that it will appear like animation. So what we want to do, if it is greater than or equal to 0, internal memory 1 should be added by 1. Okay, so it is nothing, just incrementing itself by one value, and we will close this loop. Now when this value reaches to 25, it should start from beginning. So I will write code for that. If value of internal memory 1 becomes equals to 25, it should start from beginning. That means it should start from 0. Okay, and again I will close this loop. Okay, so here our first case is completed where pulse number is 0. Similarly, we will write code when the pulse number is greater than 0. So just copy paste this, and from here, okay, first of all, so here this code is completed. Okay, from here, don't forget where this and if loops comes. Okay, because this can cause error while doing the programming or simulation. So now here I will paste that line, and here what I will do, I will change the condition. When the pulse number is greater than 0, what should happen? This time I want to increase the value of 1 by a variable. That variable depends on the frequency. As the frequency changes, that means if the frequency is higher, this animation should be faster. So that's why what I will do, I will write same code as earlier. If internal memory 1 is greater than equal to 0, okay, then what should happen? Value of internal memory 1 should increase by some variable, that is internal memory 2. Okay, we will define the internal memory 2 later words. Right now you understand, based on the frequency, this factor will increase the value of internal memory 1. And what should happen if the value of internal memory 1 should become equals to 24. Now here I have written 25 and here I have written 24 because this time I am going to use even values only. So by adding even values, it may not reach to 25 because it is starting from 0. Okay, so when it completes 24 state, it should start from beginning. So here I will write 0, it should come back to 0, and there are two if, so here I have to write two and if. So this is the complete code for movement. Now I have to write some code for this internal memory too. So what I will do, let me press this enter over here. Now I will check if my frequency, based on different values of my frequency, I will define the internal memory 2. So let me copy paste this only. Here I will change D2 because D2 is our frequency. Let us say if D2 is 100, that means 100, someone sets 100 frequency, then value of internal memory 2 should become 1, like normal operation. Now what I will do, I will use else if this. If the user enters 300 frequency, then internal memory 2 should be 3. That means the value of this will be added 3 every time. So it will increment by 3 every time. So here I have written 3. So similarly copy paste this. If user enters 600, then it should increment by 6. And similarly, if the user inserts 1200, value should be 2. Now you will be thinking, here the value is increasing, but here why 2? Because when I was trying and I have seen that if I increase the value by 2 only, then animation appears much faster. So you can experience this code when you will do simulation by yourself only. These things you can know when you do try and error things. Okay, so I have tried and error and found this code. If you confused at any time, you can pause this video and let me maximize this. You can pause this, take a screenshot of this, and you can write exactly like this and then do simulation so that there is no errors any. Okay, right now let us close this and update yes. So let me write one more note over here. It is almost completed and it's time to test whether my things are working or not. So first of all, I will open my code in the ISP soft. This I have discussed in my previous video. I will compile and download it. So it is transferring. Okay. Now click on online mode and run button and let's see whether our simulation works or not. So there is one error. Let us see that what is that error. Okay, filing screen cycle macro at. So we have to see that it's saying line number 25. Okay, line number 25. This can be error because you can see here there are three ifs, but here there are two end ifs only because this is the main end if for this one. So let us add one more end if. So this is what I was talking earlier, that we have to pay attention how many end ifs will be required, and let us try again. Okay, this time if error doesn't comes, okay, still there is one error. Line number, okay, we need to check it. Here this end if started. Okay, so you can see this if has started, but we haven't ended it. So first of all, let us end that. So we have to check from here, one if, two, three if. This ended over here, this is ended over here, and this all are okay. This two if okay. Let us check now. So you can see this time the error doesn't come. So the only error in the code was the missing end ifs. So right now, uh, this is the final code. Okay. Let us see still it is working or not. So let us see is working or not. So first of all, what I will do, we will see Dpls V instruction. Let me click over here. Okay, so it is not switching our screen. So let us fix that first. Here it is, go to screen, function, go to, okay. Let us enter simple momentary button. We'll click over it. Right over here, internal memory 10, get 10.0. In the macro, what we will do, go to others. Here you can see open screen, and here we have to select constant 2 because we want to go to screen number 2, update macro and close this. In the text we can write Dpls V. You can format your text. Here you want to go to Dpls V. What we will do, just copy paste this. Address to 11.0 and in the macro we will write over 1 over here. The text, let us write Dpls V. In this way, whenever you find any error while doing simulation, you can troubleshoot it by like this. Let us again do simulation. So first let me click over here. So now you can see we can switch between the screens. Now we will first of all see our Dpls V instruction. So first we have to write the data. So let me write 100 over here and 0 in the pulses because we have written one code for 0 number of pulses. When the number of pulses are 0, it should run continuously, okay? And this is our button. So x0 will be executed and y0 will have number of pulses. So y0 will become on. So let me press this. You can see our code is working perfectly. So in this mode, when the number of pulses are 0, the servo motor will continuously run. And when I will stop this, our motor will stop. Now we will see what is the first we will vary the number of pulses. So what I will do, first let me write, I have written code in such a way that if I write 1000 over here, it will rotate for 1 revolution. So let me close this, okay. Let me just do one more over here. Now what we will do, let me write 1000 over here. So if I write 1000 pulses over here, observe the bright blade over this, it will rotate for 1 revolution. So let us check that it is starting from 0 degree and it will complete the 360 degree. So let us check that. So it has started from 0 degree. Observe this bright blade. It should stop around here. So you can see it started from here and stopped from here. In this way, based on the number of pulses, we can get the desired angle in the servo motor. So this time let us write 500 only. Okay, press enter. So you can see our data from HMI is moving to instruction, and right now we are seeing this Dpls V instruction. This time it should rotate for 180 degree, from 0 degree to 180 degree. So let us verify that. We have to stop this and again start. So it started from here, the bright blade, and you can see the bright blade stopped over here. So we can say that approximately this moved for 180 degree. Now if I write 250 over here, it should move for 90 degree. That means from here to 270. So I am not saying that it will exactly stop over here, but it will stop somewhere around here. So let me play this. So it started from here, and you can see from here to here approximately moved 90 degree in here. But if you use hardware servo motor and servo drive, you can get precise angle based on pulses. When you will vary the number of pulses, based on this you will get the your desired position. Again, if I write 500 over here, so what will happen? It will move half rotation, means 180 degrees. So let us see that it started from here. Okay, you can see it started from here and stopped to here. So we can say that approximately it done half revolution. So in this way you can control degrees. Similarly, if you want a desired number of RPM, means in some machine you want, like in the coil winding machine, you want desired number of turns. So how you can get that? If I write 5000 over here and press enter, so observe this bright blade. What will happen? It will turn for 5 times. So let us play that. So you can see it started from here. So I am keeping my cursor over here. So now it moved one rotation. Okay, one rotation is completed. Observe the bright blade. Okay, two rotations completed. These are the three rotations completed. Fourth rotation is going on, and now the fourth rotation also completed, and this should be the last rotation. So let us verify that. So you can see it traveled little longer because this is, as I mentioned, this is the non-ideal system, but we can conclude that based on the number of pulses we can control the degrees or number of revolution. So now what we will do, uh, let it be 5000 only. Now we will see the function of frequency. You can see I have written different frequencies over here. So you have seen the normal operation. Now we will see what happens if I write 300 over here. Observe the animation. You will feel that it is little faster than before. So let me play this. Okay, you see it stopped because it was the faster. So we have to increase this, let us say 10,000. So we can completely see the animation. Okay, it exited the limit. Let us write 9,000. Okay, this is the maximum limit. Okay, now I will play this. Yeah. Okay, let us write 6,000 over here and play this. If you find any problem like this, just simply close this and again start the simulation. So this time, if I write 9,000 over here, it should definitely work. Okay, let me start this. So you can see it is working, and you can see the animation is little faster than before. This bright part is moving faster than before. So this is the work of frequency. Now what I will do, I will stop this and I will write 600 over here. So it should be faster than before. And let us play this by starting this. So this time you can see it is still. If something like this happen, you can stop this and again just start the simulation. Don't change anything else and just click over here. So you can see it is faster than the 300. Okay, similarly stop this. Let us write 1200 over here and observe the animation. Okay, so you can see the bright part is changing more faster than before. Okay, because it has completed the 9,000 pulses. Let us again start this. So you can see this, the rate of change is increased. So this is the work of frequency. As you increase the frequency, speed increases, and as you increase the pulses, degrees, or we can say number of rotation, increases. Now we will see Dpls V instruction. So here we only have one input, that is the frequency. So let us keep 100 over here, and when I press this, first of all we have to stop this and I will press the start button. Okay, let us first close this and again start this. 2-second screen, and here we will play this button. This is not working. Why? Because in this screen only also we have to copy the code, cycle code. Okay, so just close this. This is the screen one. Okay, so this cycle code only works for the screen one. So copy paste this. Now go to this screen and again go to cycle macro. So you can see this is empty. Here we have to write the code. So paste this. Let's update yes and do the simulation. So now you can see, okay, this is due to Dpls V instruction. It is continuously moving because here number of rotation or position can't be controlled, only we can control the frequency. Now what we will do, okay, we can't give negative frequency from HMI. So I will right click over here and change the present value. So right now you can see it is in the forward direction. What I will do, in the present value let me write -100. So you can see our direction bit enabled, and so it will give reverse command to our servo drive. In this way, if I give the positive frequency, here you can see, if I give the positive frequency, the direction command disabled. So this is the working of Dpls V instruction, that we can give different frequency and we can get direction from this instruction only. While in DPLSY, if I want to do reverse direction, I separately have to energize this Y1. Right now it is not able because this instruction is working. So first I have to close this. So now you can see, if I use DPLSY instruction and you want to change the direction, you can change by another instruction. You have to write another instruction for that. But if you use DPLS V instruction, direction can be changed by changing the frequency only. That is just the main difference. You can see Y1 activated, here reverse direction. So friends, from our side, this was our maximum effort to explain you the how to write the code for servo drive and its simulation. If you like this, if you want to learn more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting topic like this.